Welcome to Zuluba Consultants. In this video, we want to look at how we answer questions that have combined parallel and series circuits. Do not forget to subscribe to our YouTube channel, that is Zuluba Consultants, and the Facebook page for these and more videos. Before we can even look at this video, we have produced videos that have separated the two concepts, the parallel and the series circuit. You do well to look at those videos and watch how we apply those concepts. In this video, we are going to look at the application of the two videos that we have done. That is the video under series and the video under parallel. Once again, you do well to visit those two videos. So let's look at the first part. It is asking us to calculate the effective resistance between point X and point Y. Now, when you look at these 2 points, you'll notice that we have 3 resistors there. This one having 2 ohms is connected in series compared to these which are connected in parallel. So when you want to calculate the effective resistance, you need to add the component that is in series to the components that are in parallel. So what are we simply saying? We are saying the total resistance is equal to the parallel resistance plus the resistance in series. So the resistance in series, we already have it. It is 2 ohms. The resistance in parallel, we need to resolve these two resistors. So we need to apply the concept of finding resistance in parallel circuits. We know that resistance in parallel, we find it as 1 over total resistance is equal to 1 over R1 plus 1 over R2. Now, when we get the R1, we are saying it will be 1 over 12 plus 1 over 6. After you do that, you are saying resistance that is in parallel is equal to, you get the common denominator there. The common denominator is 12. 12 into 12, it is 1. 1 multiplied by 1 gives us 1. Plus 6 into 12, it goes 2 times. Multiplied by 1, it gives us 2. So when you add this 2 and 1, it gives us 3 over 12. So we are saying 1 over R parallel is equal to 3 over 12. When you cross multiply these two, you will have 3 R parallel is equal to 12. You divide by 3, you divide by 3. This will simplify. You have R parallel is equal to 3 into 12. It gives us 4 ohms. So this is the effective resistance that is being produced from these 2 parallel components there. Now, remember, we have said the total or the effective resistance between point X and Y is the combination of the resistance from the parallel plus the resistance from the series. So we can go back now to this equation. So the effective resistance is equal to the resistance from the parallel, we have calculated it is 4 ohms, plus the resistance from the series, we have it as 2 ohms. So the effective resistance then becomes 4 plus 2, which is 6 ohms. So we can even put this information here to say the total or the effective resistance is 6 ohms in this circuit. Let us look at B. It is asking us to calculate the current that is passing through the battery. So they are asking us to get the current that is passing through this point. Now, what do we know about current? For us to easily find that, we need to apply the Ohm's law. So the Ohm's law tells us that resistance is equal to voltage divided by current. So when we are finding the current, we'll say current is equal to voltage divided by resistance. Now what is the information that we need to have regarding this question? The first one is the voltage. The voltage we have been given in the question that it is 12 volts. Then when we look at resistance, this is the effective resistance that we found in part A. So the effective resistance that we got is 6 ohms. So we can now put these two values in our equation. We are saying current is equal to 12 volts divided by 6 ohms. So current is equal to 6 into 12. It gives us 2 amps. So this is the current that is passing through this battery. And we can put this information here to say the current passing through the battery is equal to 2 amps. Let us look at the third question. The third question is asking us to calculate the current that is flowing through the 6 ohm resistor. So they want us to find the current that is at this point. Now, before we can look at how to calculate the current that is at this point, there is one important information that we need to remind ourselves regarding these two parallel resistors. Remember that we said the total resistance at this point is 4 ohms. So 4 ohms is the total resistance that is at that point. So basically we are saying these 2 ohms and these 4 ohms, that is as a result of the total from these two parallel, they are in series to each other. Now, what do you know about series circuits? With series circuits, we say the current is the same. So if the current is the same in series circuit, it simply means at this point, the current that is there is 2 amps. Even at this point, the current that is there is 2 amps. So if you know the current that is coming at this point after the resolving of these two parallel resistors, we can use these 2 amps and the resulting resistor here to find the potential difference or the voltage that is reaching these two components. So that's the first thing that we need to have. We need to find the voltage. So we need to find the voltage as the first thing. The voltage that is reaching this part. So we have said we can get some information there that the current that is reaching this point is 2 amps and this point has the effective resistance of 4 ohms. So if you have these two, we can use this Ohm's law to find the potential difference or the voltage that is reaching these two parallel circuits there. So the voltage is equal to, we are saying, resistance multiplied by current. So resistance is 4 ohms. Then we are multiplying with 2 amps. We are saying voltage here will be equal to 8 volts. So this is the voltage that is reaching the parallel circuit here. So if 8 volts is reaching these two components, we now borrow the principle that is at parallel circuits. In parallel circuits, the voltage is the same on the two components. So the voltage does not change. This simply means this first resistor has 8 volts and this other one also has 8 volts. So if this component has 8 volts and the other one has 8 volts, we are saying in parallel the volts that is coming, or the potential difference that is coming at this point, is the same. So if you know that now, we can use these two figures to know the current that is as a result of this resistor. What will be the current now at this point? So let's calculate the current at that point now. So we need to get some information for that point. The first one is the voltage that is reaching this point, which is 8 volts, and also the resistance at that point, which is 6 ohms. Then we know that current is equal to voltage divided by resistance. So this simply means we are saying 8 volts divided by 6 ohms. So 6 into 8 on your calculator, it should give you 1.33 amps. So this becomes the current that is reaching this resistor.